Hey, what's up, guys? Okay, so recently I found a video. It's going talk about the so-called Jordan's inequality. Okay, so basically I heard this inequality. I guess that I heard it from like high school, right? But I haven't really like go through a proof. Okay, so I will quickly go through a proof, and it's very elementary, and the proof is very simple. And I will give two proofs. So the first, let me see. So idea is that you start with this region and you claim. So this claim is basically this. So yeah. Okay, so this is what we are going to show. We want to show that when x belongs to 0 into pi over 2, that 2 divided by pi x, that's equal to sine x, that's equal to x. Okay, so let's say this is part 1, this is part 2. Okay, so the part 1 is simple, right? So if you know something like you can prove it geometrically. So let's say this is x, 1, this is x, so this is sine x. Okay. And this is not important, right? But you can, let's say you compute this triangle, the area of this triangle. So let's say this is AB 0. And so let's say the area of this triangle, this 0 AB, is that's equal to the area of this shaded region. Okay, so 0 AB. Okay. So this is x, this is x. Okay, so now it's like trivial, right? So this area is half of sine x. This area is half of x. So basically show that sine x, that's equal to x. And obviously here, right? So if x is non-zero, then basically you can, if x does not touch this boundary, it's obviously that this will be less. Okay, and so 2, right? So there's the quick way to prove 2 is you know the following, right? You can like this is like pi over 2, and this is 1, right? So this is your sine. And you know that if you plot this line, and this line is like 2 divided by pi x, right? So if you know this, then you can easily prove, right? You can easily see that this region, this curve is larger than this is larger than this, right? So sine x is greater or equal to 2 divided by pi x. Okay, but this proof is basically a little bit cheating, right? Because I mean, you need to use a calculus, right? So let me just prove proof 2 using calculus. Okay, so what I want to say is that proof 2 looks a little bit cheating, right? It's a little bit cheating. Okay, so we want to do it. Using calculus. Okay. By the way, one can show number 1 using calculus. Okay, so let me just quickly do it, right? So I can define f to be x minus sine x. And I know the f derivative is 1 minus cosine x greater or equal to 0, right? So by mean value theorem, I say f of x minus f of 0. There exists some c belongs to 0x, such that f prime of c, x. Okay, and I know that f prime of c is greater or equal to 0, so I can plug it here. So I know greater or equal to 0. I know that 1 minus sine, x minus sine x is greater or equal to 0. Okay, so let's go back to number 2. Let's go back to number 2. So this proof is a little bit tedious, but let me just do it. Okay, so the goal, right? So let me just write down the goal. The goal is to show the following. Okay, so I can define a number. Let's say I define a number x0, basically is it's basically r cosine 2 divided by pi. So what this means is basically say that cosine x0 is greater is basically 2 divided by pi. Okay. So now I can consider the 2 regions. Okay, so notice that the cosine is decreasing when x increase from 0 to pi over 2. Okay, so let's consider if x that's equal to x0. In this case, that what I know is that cosine x is greater or equal to pi 2 divided by pi, right? So what this means that I can write sine x using the calculus, right? So I can do the cosine integration. So it's cosine y 0 from x. I know this, right? Because I know that x is equal to x0, so I can replace this by x0 to divide by pi dy. Okay, because I know this. I know x is less or equal to x0, and now I know that the I know cosine is basically decreasing. Okay, so now this is 2 divided by pi x. Okay, so the next step is to show another way, right? So to show basically another situation. So another situation is that when x greater than x0, so when x greater than x0, that what I know is basically cosine x less or equal to 2 divided by pi. Okay. So now I can use I'm still using calculus, right? So I know that if I can write like if I do a differential, if I do integral from cosine y from pi over 2 and x, then I will get sine x pi over 2 by x. So this is y. So this is 1 minus sine x. Okay. So I can write sine x equals to 1 minus pi divided by 2x cosine y dy. Okay, so now in this case that since I say x greater or equal to x0, right? So my cosine is less or equal to 2 divided by pi. So what I can say is that pi divided by 2x cosine y dy is less or equal to pi divided by 2x and dy, right? From here, 2 divided by pi. Okay, so what this shows is that 2 divided by pi divided by 2 minus x, which is 1 minus 2 divided by pi x. Okay, so why I have this? I can plug it in, right? Because it is less or equal to, so this becomes 1 greater or equal to 1 minus 2 divided by pi x, which is exactly 2 divided by pi x. Okay, so what we show is that whether x less or equal to x0, then we always get this. When x greater x0, then we still get it. Okay, so this is basically the rigorous way of using calculus to show this number 2, and the first one is also rigorous proof. See you guys next videos.